Hello everyone. Today we are going to start our first chapter, interfacial phenomenon. Now, as we have discussed earlier that when there is two phases, one is solid and one is liquid, then there is a boundary between that two phase. Okay, so this boundary is called as interface. Okay, and the second word we have discussed is surface. Generally we are going to use word surface, right? Why? Because when we are dealing with the normal substance like water in a glass, then the one of the phase is gas. Okay, so when one of the phase is gas, then it is called as surface, right? So generally when you have the solid surface, when you have the two solid surface, then between two solid there is an interface, but between solid and gas there is a surface, between liquid and gas there is a surface, right? So first, today we are going to clear about surface and interface. Okay, now see this figure given in 5.1. You are having a solid phase placed in the air, right? So solid substance is there, so surrounded the solid substance we have air. Okay, so between air and solid we have boundary that is called as solid gas interface. Okay, now second figure B, we have a beaker filled with liquid. So liquid surface is there, water is filled in the beaker, then we have the liquid surface, and above the liquid surface we have gas. So between gas and liquid there is a boundary that is again called as liquid interface. But when one of the phase is gas, then it is called as surface. That's why in both the figure it is written like solid surface and liquid surface. We are not going to use the word like solid gas interface or liquid gas interface. Okay, so if one is the gas, then you have to say it as a surface. Okay, so clear about surface and interface. Okay, see now the second example. When solid is placed in the liquid, okay, solid is placed in the liquid in the figure C. So it is there is a boundary between solid and outer liquid in the beaker. Okay, in the figure C. Fine. So when you have this solid placed in the liquid, for example chalk piece, when you put the chalk piece on the liquid in the beaker filled with liquid, then there is a formation of boundary between solid and liquid. बने बच्चे boundary बन से. Okay, and that is called as your solid liquid interface, right? In that there is no gas phase. So here the two phases are solid and liquid. Okay, so this is called as interface. Now check the figure number D. When you have two liquid in the beaker, see, you have filled water and CCl4 in the beaker. So CCl4 is on the top surface, water is at the bottom surface. So when you fill both, then there is a boundary between two layers and it is called as interface. Between two liquid, between solid and liquid, it is called as interface, and between solid and gas, liquid and gas, we have the surface. Okay, so are you clear about surface and interface? Okay, now second concept is at the surface there is a surface tension. Okay, so what is surface tension? So it is defined as the force in dyne acting on the surface of liquid at right angle to any line of the length of the surface, 1 centimeter, right? When you have a surface of 1 centimeter area, 1 centimeter area નું surface છે, એની ઉપર એ લાઇનની ઉપર at the right angle any force is acting in the line, then it is called as its surface tension, right? એક સરફેસ છે એનો એરિયા કેટલો પકડવાનો 1 સેન્ટીમીટર એરિયાની અંદર. ઓકે, રાઇટ એંગલ પર જે ફોર્સ એક્ટ થાય છે દેટ ઇઝ કોલ્ડ એઝ સરફેસ ટેન્શન. દેટ્સ વાય ધ સરફેસ ટેન્શન ઇઝ મેઝર્ડ ઇન ટર્મ્સ ઓફ ડાઇન પર સેન્ટીમીટર, મતલબ ફોર્સ અપ્લાઇડ પર યુનિટ ટાઈમ. ઓકે, और पर यूनिट ए नॉट टाइम, पर यूनिट एरिया. मतलब 1 સેન્ટીમીટરની અંદર ફોર્સ લાગે છે કે 2 સેન્ટીમીટરની અંદર. દેટ્સ વાય ઇટ ઇઝ ધી ફોર્સ અપ્લાઇડ પર યુનિટ એરિયા. દેટ્સ વાય ધ યુનિટ ઇઝ ડાઇન પર સેન્ટીમીટર. રિમેમ્બર ધીસ, યુનિટ ઓફ સરફેસ ટેન્શન ઇઝ ડાઇન પર સેન્ટીમીટર સ્ક્વેર ઇન CGS system. Newton per meter is also unit of surface tension, right? We can also say the unit of surface tension as a Newton per meter square. Okay, in MKS system. So here it is clear about what is surface tension and what are the units. Now, to why we are going to study surface tension, what is its importance in the normal day-to-day processes. So where we can observe the concept of surface tension, so here there is a given example. What are the example? The formation of spherical globules in the emulsion. When you mix oil with the water and you stir it in the mortar pestle, then your oil globules is converted into rounded shapes in the water. Okay, oil is in the form of round shape in the water. So why they acquire rounded shape globules? So between oil and water they offer surface tension, or interfacial tension is there between oil and water. Okay, that's why they remain separated. So because of the surface tension there is a formation of spherical globules. Second, the formation of nearly spherical shape of the falling water droplets. When you have any water coming from the tap, okay, slowly, then what is the shape of the droplet? A droplet no shape કેવો હોય? When you drop a liquid from the pipette, what is the shape of the drop? Any drop is having spherical shape. Why? Because any falling liquid is under tension, because outside atmosphere is different than its inner bulk. Okay, that's why it is under tension. That's why it acquires spherical shape. Okay, and the third example is formation of spherical shape of mercury particle on the flat surface. Yes, now check paro. Have you seen mercury or paro at your home? When you drop your mercury metal on the surface, it forms rounded shapes. Why? Same, it is again under tension. Material is under tension. Okay, so this is one of the again example of the phenomenon of surface tension. One more example is rise of the liquid in a capillary tube. Matlab, take a beaker, fill it with the water thi bhar nakho. Now take a capillary. Okay, now measure the height of the liquid in the beaker. For example, you have filled it up to 5 cm. 5 cm ની height સુધીમાં તમે પાણી ભર્યું છે. Okay, now place a capillary in the beaker and then check the rise in the height of the liquid in capillary. તમારા બીકરમાં 5 સેન્ટીમીટરની હાઇટ છે પાણીની, but in case of capillary it rise up to 7 centimeter automatically. Why it happens? So this is because of surface tension, that there is a rise in the liquid in the capillary tube. Okay, now one more example is phenomena is formation of hemispherical surface. Matlab, when you see the liquid in your pipette, then it shows lower meniscus. It never shows upper meniscus. Lower meniscus is there on the surface, right? જે બી surface પર liquid છે ત્યાં deep curvature જોવા મળશે in the pipette, right? So this lower meniscus is because of the surface tension on the liquid. Okay, so these are the phenomena that we come across the day-to-day life, where we can observe the phenomenon of surface tension. Okay, clear? Now, in the phenomenon of surface tension, in case of liquid, what happens in the liquid? The molecules experience greater attraction from the neighbor molecules, right? Suppose we have the glass full of water. Then in the water, there are a lot of water molecules, okay? So they shows greater attractive force to the neighboring molecules, okay? Such intermolecular attraction between like molecules are called cohesive force, while attraction between unlike molecules are called as adhesive force. Okay, in the molecules there is a force of attraction are there. Suppose between two like molecules of the water, it is called as cohesive force. Between two unlike molecules, matlab sugar and water, right? So this is unlike molecules. Two molecule of water, it is called as like molecules. So between like molecules there is a cohesive force. Between unlike molecules there is a adhesive force. Okay. Now surface tension denotes cohesive force between the liquids, right? Okay, because its interaction with the air is less. Okay. Okay. Now see this table. What it indicates? The surface tension of the liquids. કેટલું હોય છે, right? You should know the surface tension of the commonly used liquids. See methanol 24.49 dyne per centimeter. See the unit of liquid. Then benzene, toluene, see all are having nearly same surface tension. Okay, but we should know, and see during writing of the surface tension we should write temperature. Okay, this is the surface tension at this temperature. Okay, and see in the second table, check the surface tension of water. You always remember the surface tension of water, right? It's always write as 72 dyne per centimeter. Practically how it is written? So 72 dynes per centimeter. Okay, see surface tension of mercury, how high it is, 480 dynes. Okay, so these are the liquids. Sometimes we have to remember this. Okay, now see, take a one practical session to understand the concept of surface tension, right? Now take a water and a beaker. Okay, now molecule in the bulk of the phase, see figure B. Okay, see this figure C, very nicely given in this book. See the molecule S and molecules B. What it indicates? Molecule S is at the surface and molecule B is in the bulk. Okay, so in the bulk it is attracted equally by every molecule is attracted equally, right? So it is balanced in the bulk, right? But those molecules which are at the surface ઉપર જે molecule છે, it is attracted from the molecules which are inside it. એની ઉપર કાંઈ છે જ નહીં, ઉપર હવા છે, right? So no one can attract it. Okay, now જે બલ્કમાં molecules છે, they are attracted by these like molecules. Same cohesive forces are there from all the sides. Okay, so it acquires spherical shape, right? So to reduce the surface to minimum, they try to reduce its surface by contracting. Okay, so it is under tension. Okay, so force acting on the surface of the liquid is called as surface tension. See, those molecules which are on the surface, they are acted upon the force, right? But those which are in the bulk, they are balanced, right? That's why those molecules on the surface, they have some surface tension. Okay, Now what is clear why they have the spherical shape? Because all the molecules on the surface are attracted inside. That's why they shows spherical shape. અંદર ખેંચાય બધા એટલે એનો spherical shape ગોળાકાર થવા માંડે. Okay, when you drop a liquid in the form of droplet. Okay, now what is interfacial phenomena? The interfacial tension is again same force per unit length existing between two immiscible liquid. બે liquid છે જે કેવા છે? Immiscible છે. ઓકે, અને બંને